Now recording.
Cheers. Hello everyone, and welcome to the third day of our Unlocking Innovation event on developing whole systems in the digital age. For those who haven't been here for the last couple of days, I'm Carl King and I'm one of the technical innovation managers at RIA. I actually have our other T&I manager, Sam Bevans, also on the call and will be helping me today. So be sure to say hi to Sam later on. Thanks for attending, and if you there he is just waving in. Thank you, Sam. Thank you for attending, and if you keep your cameras and microphones off while we've got the presenters on, but there will be, during each presenter's presentation, there'll be a Q&A session where I'll invite people to come up and ask questions, and you may turn your cameras and microphone on for those. And also at the end of the event, hopefully we'll have some time for some networking and a bit more of a wider panel discussion and so forth. If I could just say though as well that if you while the presenters are presenting, please feel free to use the chat function to put any questions that come to you down. We will record those, and then also I'll invite you up to ask a question physically when the presenters have finished their presentation. We're going to go through on Monday we discussed how we'd define problems for complex systems, and yesterday we looked at how to develop requirements. Today, we're going to look at how do we actually take those through to developing into solutions, and how do we ensure that we have the right procedures and policies in place that we can deliver them through complex projects. And I'm really pleased to say we've got some excellent speakers again today. We're going to be starting off with Derek Price, who's already got his camera on, who's going to be talking about Network Rail's new systems integration framework, which I'm sure a few of us have quite a few questions about. We've then followed by Professor Clive Roberts and Dr. Heather Steele from the University of Birmingham, who are going to talk to us about synthetic environments or digital twins, as some of us call them, and how what role they're going to play going forward in assurance, and how we can use them to test things without using the live railway. And then finally, I'm really pleased to say we've got Andrew Simmons, who's the head of the Technical Authority for Digital Railway and other major programs, and he's going to be talking to us about insurance and where we should be thinking about assurance in the life cycle. And I'm looking forward to that. And we're also going to close off with a couple of elevator pitches from two of our members, Harmonix and SEMP Limited. Really excited to have those aboard. Those will be done by Paul Whitcomb and Stuart, respectively. So we'll start with, let's get straight into it. I'd like to start, if I can say, as I said, you can see Derek Price on your screen at the moment, whose career largely has been focused on the application of systems thinking to major infrastructure projects, which he's done across transport, power and the defence industries. And he's worked on both sides of the fence as well as sitting on it. In other words, he's been a supplier, a consultant and an approver in one of the regulator, owner and even an operator in his time. And he's has seen the state of practice developed over 2 decades now, which was very bold of him to admit. Yeah, no, I wouldn't have said that, Derek, not at all. His current role for Network Rail is the technical head of discipline for systems integration. And in that role, he's to direct, plan and assure system integration activities related to delivery of projects and programs across Network Rail's infrastructure projects. He's proud to be a founder member of the Incosi Railway Interest Group and is Network Rail's representative on the Incosi UK Advisory Board. His hometown is, he also asked me to point out to you that his hometown is Darlington, very near from where I'm from. For those of you who can't guess, I'm a smoggy, i.e. Middlesbrough. And but Darlington was where the world's first public passenger steam railway system started service in 1825. So Derek certainly didn't set out to become a railway man, but the complexity, scale and challenge and opportunity to forge a path as a systems engineer in this critical sector became irresistible to me, he tells me. So Derek, I'll hand over to you now. Thank you very much.
All right. Thank you, Carl, and thank you to RIA for inviting me to give an opportunity to share this. I'm going to try and keep this fairly tight. There are some longer presentations available, and I've provided some links to those things at the back end. So I'm Derek Price for Network Rail, as Carl said. After hearing the presentation discussions on Monday, I've tweaked the presentation a bit to keep it down to time and keep it shortish, but focus on what we did to listen to the customer. We talked about the voice of the customer on Monday quite a bit. So I'm going to dwell on the drivers for why we introduced some of these changes in the integration challenge. I'll very briefly talk about what the system integration for delivery framework is. Very briefly, I've got quite a neat 5-minute animated video, which does a much better job of describing it than me trudging through some slides. But it's a brief run through. I'll then talk a bit about the feedback we've had so far since its launch last summer. And some of it's quite interesting. I think is we're certainly going to take a lot of that forward and might be meaningful to other people looking to make similar or other changes coming up over the next year or so. And then talk a bit about what I think is going to happen next, and try and put it into context with some of the things that Carl's got in the session on Monday and today. So, as some of you might know, in terms of the integration challenge, there's been a series of internal and external reviews of both Network Rail and the UK infrastructure sector practice in its wider sense, which together all called for greater focus on a whole system approach, integration of different elements of the project design, planning and scope definition of projects in an early phase, resisting scope creep, learning from successful programs, ensuring clear organizational accountability of system integration. And one of my favorites is this one, the IPA Lessons from Transport for the Sponsorship of Major Projects report. This is an IPA DFT report. It is littered with the word system integration and littered with talking about dealing with system integration risk. Did a word count 47 times. It has 5 fundamental themes. One of those themes is deal with system integration risk, which is a great driver and makes it easier for me and our organization to convince people to pay attention and do something. And most recently, this got mentioned on Monday, the civil engineering profession themselves have looked into this and produced a report, a systems approach to infrastructure delivery. And again, this is a great sales pitch for me as a systems person. This is the civil engineering profession looking at it saying, this is really important. We have to do more of this to make our sector work well. And as you see, it says, the current model for complex projects is leading to far too many projects running into problems. This can be avoided if the sector embraces systems thinking. So I really like that. When I'm doing internal presentations, we do a lot of lessons learned and share specific issues that have cropped up on specific projects to make it clear to people that this is not an abstract thing. This will help materially the delivery of day-to-day projects. Now, I've sanitized this and taken names out. One of the really big ones for our customers and our users was we all know that there's a very clear system safety approval process, the CSMRA standard. But it's also true that lots of people don't understand it very well and have difficulties following it unless you're a specialist. And that creates unexpected time pressures prior to commissioning. It often means that critical project dependencies are sometimes not identified until late on in the life cycle. And the flip side is because of the uncertainty about how to use and perform system safety analysis, we have circumstances where there's inefficiency introduced and delays due to sometimes unnecessarily detailed analysis. And that's because of things like inconsistency in the guides and the training we've done collectively. And we've done a lot of work to pull and tie that together. The second one is to do with the alignment of infrastructure capability within service performance, i.e. we're building some new infrastructure. How confident can we be, and how confident can the operator be that will support the timetable change coming up? It's a fairly simple proposition, but we're all aware of situations where it becomes a bit more complicated than that. We don't quite hit all the right buttons. And I'm sure all aware of opportunities where there's been a missed opportunity for one reason or another for the operator to get a view early on, or even late on, to really know whether the change to infrastructure capability will support an expectation of timetable service performance. I've got a good news story, and it's not all bad news. There are some really successful projects that do this really well. And because it's successful, I'll say what it is. It's Thameslink. This was based on a specific scenario around the London Bridge Station area, some years before the first big timetable change, and some really well planned, commissioned performance modeling and simulation work was done in collaboration with the industry operator and the DFT to identify that the reasonably optimized infrastructure was not going to quite hit all the timetable service requirements. So that meant that through this, the sponsor was able to work with the industry stakeholders and renegotiate the timetable change in advance of the main plans. And I'm sure you could think of many more instances. So in Network Rail, we used our formal risk management regime to create some very specific enterprise risks specific to system engineering. What that meant was, it meant the work we did was driven as part of a core business change. It wasn't a peripheral thing where we were asking people politely or nicely if they wouldn't mind listening to our system integration words. Another part of the challenge was to recognise context. Context is everything. And I've stolen this diagram from the Civil Engineers report to illustrate the point that there's many different kinds of life cycles. I'm sure you all know that. But in terms of infrastructure, the primary one we should be thinking of in some ways is the use. There is a life cycle of its own that is the operating and maintenance of an asset for a purpose. In our case, it's a railway. Then off on the side here, there's the process of making changes. So we plan, design, build, commission, and back in. And we're just starting off with a conversation internally to more clearly communicate with ourselves. When we're talking about system engineering, system integration, we have what we call capital delivery. That's making changes to the fixed railway infrastructure. We have the complexity of running an in-service railway. And then there's complexity associated with creating new products, changing new products, research and development. So for me, my core day job, this presentation, is primarily focused on capital delivery. We've got people like Andrew Sims later on talking about digital, where it's much more fuzzy than that, and the complexity is there, but it's different. This is another one that sets out the challenge and the business drivers for doing what we've done. This is a distribution of our typical project size and complexity. You'll probably notice this is 2013, so it's quite old, but the lessons to draw from it haven't changed, I don't think. So it shows we've got a large number of relatively simple renewal projects, average value 2.3 million, a handful of major programs, so that's the like of TRU, Thameslink program, things like that, and some in between. Now, I think it's fair to say for major programs, you tend to find that they have some seasoned practitioners in there, and they have conversations about how to do system engineering or integration well, not why. And we really do think that the sweet spot is that there's an opportunity to enable projects of low or medium-sized complexity to take advantage of some system integration activity, not all of it, but in a very carefully scaled, tailored way. And that, in essence, is one of the primary drivers of the framework we introduced. So what is system integration delivery? This is a really quick potted version of it, and there is more longer briefings available. We tried to take the generic language of system engineering and present a framework which uses language which is more immediately related to railway infrastructure projects. So instead of using the word emergent properties, the way our systems people do sometimes, we talked about 7 system integration themes, and you'll see those in a bit. They're to do like performance, reliability, safety, security, etc. We haven't produced a management manual or a separate management framework for doing this. We've created the framework that embedded it in existing ways of working. It just works better, it's easy to sell, it's easy for people to adopt, and it's easier to cope with changes later on, and I'll touch back on that later on. It's explicitly designed to tailor to areas important from a system integration point of view. And as Mike Moreau mentioned on Monday, it's intended to be scalable to project size and complexity too. So we created a framework, but there's 2 elements of it that are absolutely crucial and took up just as much effort as designing and writing the process and procedures and how to do things. And those were the comms campaign. So these were flyers, post-it notes, websites, videos, national roadshows talking to people, the development of awareness and practitioner training material, a company system integration, system engineering handbook, and giving people route maps and roadmaps to developing their own capabilities as well. So where are we today? We finished the launch, which constituted something like 30 pilot projects, and notwithstanding all the transition with our reorganization and the COVID pandemic, we are ramping up. We've got something like, I did a check a couple of weeks ago, something like 100 projects in flight applying the system integration framework. We've used some KPIs initially to test the rate of take-up. We're now looking at using KPIs to measure the effectiveness of the framework. Is it creating the business benefits we want it to? And introduced a maturity benchmarking scheme called SI Gauge. And one key, absolutely critical element of it was, we talked about listening to the customer on Monday. We have used and worked with our suppliers and our customers to develop and write the material as well. So what I'm going to do now is play this video, and hopefully it works okay.
Systems Integration for Capital Delivery, or SI4D for short, is the new engineering delivery framework for everyone involved in project delivery for Network Rail. Compliant with all relevant legislation, for example the common safety methods, SI4D has been designed to ensure we're delivering a safe, secure, operable, maintainable, reliable and performing railway, fit for the future. A railway that puts the needs of our passengers and freight customers first, a business that's easy to work with and delivers value for money. SI4D provides a standardized and robust approach to the delivery of an integrated railway, based around 6 key themes. System safety, making sure people aren't hurt as a result of the changes we make to the railway. Maintenance readiness, making sure people have the right skills, tools and regimes to preserve the delivered assets over their life. Operational readiness, making sure we supply the necessary capability and processes for new and modified infrastructure to facilitate continued operation of the railway. Security, making sure we identify and protect the railway against cyber and physical security. Reliability, making sure the changes we make to the railway deliver the expected reliability of the new infrastructure and wider railway. Railway performance, making sure projects maintain or, where required, improve the overall performance of the railway service, timetable and quality. Underpinning each theme is a suite of processes and tools for you to use in support of your work. SI4D comes into play at GRIP Stage 2. This is where you use the new SI4D triage tool to determine what SI4D effort is required according to the novelty and complexity of your project scope. The triage tool enables a risk-based approach to delivery, using a standardized, consistent approach across all projects. Your first step is to map your project elements and interfaces within and outside the system boundary, using a context diagram as part of the system definition. From here, you can identify how each SI4D theme is impacted. For example, will there be a safety and/or security risk arising from a change to a particular interface? Use system definition to answer the questions on the 6 decision trees, 1 per theme. The outcome of this will be a risk rating for your project in each of the 6 key areas. This rating will direct you to a specific delivery path for each theme. 1. Your project involves novel and/or complex changes. You need to plan and deliver significant SI4D effort. 2. Your project involves conventional and/or simple changes. You need to do some SI4D, but with a focus on assurance against existing standards and good practice. Or 3. Your project involves changes with no impact on the theme. You do not need to do any SI4D activities and can rely solely on assurance against existing standards. The output from this exercise is then documented in the supplied templates. You submit your triage assessment to the Network Rail Acceptance Panel for ratification of your system safety assessment. Whilst initially this process might be a little more systematic than your current planning method, it will ultimately save you and others time later in the process and de-risk delivery of the project scope. With time, as we're all going to use the same approach and the same templates, we'll create a library of best practice SI4D artifacts and supporting materials for you to use and get a head start with planning new projects. Once your delivery path is confirmed, you use the relevant SI4D tools and processes accessible via the Integrated Management System, IMS, to support you in the delivery of your project. Most of these you'll already be familiar with. All of these have been designed to make this process as easy as possible for you. The triage assessment is completed as a team, ensuring all the relevant competencies and points of view are covered. You may need to think about bringing in expertise outside of the project team to support this activity. And if your project scope changes at any point, you go through the triage assessment again to see if your delivery path is affected. There's lots of support and guidance available on the SI4D Hub and from the SI4D Centre of Excellence team. SI4D challenges you to take a longer-term view of the impact of your project, always keeping the project end goal in mind and putting the needs of our passengers and freight customers first. We all need to play our part in making SI4D a success. Visit si.hub.networkrail.co.uk.
Okay, so hopefully you're able to see that it was intended. So I'll just pull the screen up again. Right, so you'll see, although that was obviously a video for our audience, rest assured, underneath it, there is a system engineering style model of processes, products, frameworks, swim lanes, product descriptions, competency profiles, and training modules. We've just tried to turn it into language that's more easily understood by our audience. So, looking back on implementation, I think the launch has been a success. There's a lot of factors involved in it, but I think the key one was focusing on our customers and the users, listening to them and staying with them, recognizing what we could be seen as being disruptive because of the terminology, some of the concepts, but actually convincing them it's not as disruptive as it might be. One of the really good bits of feedback we've had from some people, which were quite key players really, were that it's very easy to be skeptical of a systems sales pitch or a systems argument because of the terminology we use sometimes and their confidence based on previous experience. But we are finding people saying things like this: any degree of skepticism quickly dissipates once guided with the right help through first application. So there's a limit to the effectiveness of presentations, one-way things, however slick they are. We're pleased to say that we have provided a simpler route to projects to manage compliance with critical regulations and legislation such as system safety, security, and interoperability. We are seeing that scope and performance issues are being flushed out and raised earlier, so we're achieving that famous left shift that we look to achieve from applying systems methods. It's very clear that it's critical for the teams to have the right level of presence and access to a seasoned system integration practitioner. So that's not somebody embedded to a project full-time. That's enough of the right touch and support and relationship with somebody who can talk their language and translate for them. After the first pilots, we've seen it's important for teams to get the right support to continue the tailoring and the triage activity. I think we can all see that sometimes it's tempting to take an easier steps sometimes and go back to including all the deliverables again, because it's easier rather than the slightly difficult process of how complex is my project, what do I really need to do. Pleased to hear that people think we're producing tangible and pragmatic guidance. And I'm pleased to say I really do think the strength of the message is getting across that this systems thing is not a niche specialism. What it produces is a way for all the project actors to collaborate and work together in a way which is holistic and pulls things together, and it's a better working experience. Another interest lesson for me particularly was the work done on the training and capability development. We worked with some of our suppliers as well to produce some really nice explanation of some of these abstract concepts of V&V and requirements and lifecycle approaches. The most powerful thing is taking people through an application of this on one of their projects as their training exercise. That's probably been the most powerful method of achieving learning outcomes. And we're doing it for time, Carl.
You're okay, Derek. Don't worry about another couple of minutes. Go another couple of minutes, man.
All right, thank you. Looking forward, what's been nice is there's been an internal pull for more. So the first year was pushing something into the system, if you like, into the organisation. We were back in the last year asked to extend the application quite sensibly, really, to include interoperability into it as a 7th theme. And we're working with the Network Rail sustainability team because they'd really like to include sustainability because, for us systems people, that's an emergent theme, emergent property of a complex system. Mike Moreau also mentioned on Monday that we are working out and playing around with how this scales up to major programs. You may recall a sweet spot was the large number of low and medium complexity projects. So generically, yes, the framework scales up. And I think we've been talking to people like Darren Jowett, and who's on his day with digital, and some of the people working on the T190, kind of playing around and discussing in what way this might work up on a major program. If it's anything other than just mapping from one to the other. And you've probably heard about the transition from GRIP, that's our project lifecycle standard, to PACE. We're working really closely with the program management team on almost hardwiring the system integration stuff in there. There's been no temporary hiccup in any way to not want to continue using this as part of the program management framework, which is great. Clearly, when business as usual, and the clear danger there is to slow down and think, yeah, we've done that. Phew, take a breath. It's really important that we keep momentum on this in the right way to tailor with the needs coming up for the next couple of years. One of the overriding observations we keep coming up with time and time again is that although we've written a set of processes and products and suites and guidance, the quality of the people, the specialists, the non-specialists, a genuine collaborative working environment is at least as important as the rigor of the process we put in place. And in some ways, it can be more important than the rigor of the process. Resilience to change over the last year. A big test of the framework has been the events of the last year. In addition to a major reorganisation of project delivery, the pandemic has also accelerated some step changes through things like the speed initiatives to a major reorganisation of project delivery and the lifecycle framework from GRIP to PACE. So far, the framework, with its focus on a holistic approach, outcomes, characterization, tailoring and scalability, is lending itself really well to the new paradigm. We didn't write a detailed handbook of how to design and develop things. We've written a framework how to make sure you're asking for the right thing, that it's going to fit into the wider system, and you've got a mechanism for an interaction between a client, a buyer, and owner, and the body making the change. And that's really coming through strongly, I think. Having heard some discussions on Monday, I quickly thought, well, what does this mean for the digital landscape? And I've mentioned we'll be talking on and off to people in the digital team and T190 and other people. And I think the focus on the holistic thinking and outcomes means it's amenable to reuse or playing around with the tailoring in some way. Comparing infrastructure projects as a classic bread and butter activity to the digital world, if you like. I think for this framework, there are things that carry through. For example, treating the humans as part of the system carries through. This framework allows life cycles to be treated in a more complex way, that are not likely to be simple sequential life cycles anymore, if ever they were. So it's still all about the context of making changes in a complex system. One parting comment was, back in the McNulty days, a guy, Duncan Kemp, who's over at the MOD, and Paul Davis, who was with us for a while back in defence, the observation of in the defence sector making the change to what they call network-centric warfare for normal operations, so much more reliant on use of live data and digital systems, was they were surprised to find they had an exponential increase in the skills demand for systems people as their activity got bigger. So that's my last slide. You're pleased to know there's a final slide just with some links to our hub site and a much longer webinar which goes into a bit more detail of the framework. So I'll wrap it up with that, and thank you very much.
Thank you, Derek. That was very interesting. We've got a few questions here. I think if it's everyone's okay, we'll have at least 5 minutes for questions with Derek, and then if anything more crops up, maybe we can have some discussion with you, Derek, at the end of the event sure. As well. If you can stay on, that would be brilliant. Thank you. And Matthew, I know you've mentioned about Derek briefly touched upon the fact that about PACE. Do you want to elaborate? Is there something you want to ask particularly about PACE, Anne, or would you like to? Do you think Derek answered it towards the end? Sorry, Anne, are you still on?
I think Derek, I was a bit ahead when actually Derek presented the relationship with PACE. So yeah, I can see it's been looked into.
I'll give a very quick answer in the sense if anybody's familiar with the structure of PACE, the system integration products are included in the PACE product index, and the requirement to follow the integrated engineering lifecycle is still written into PACE. So some of the basic fundamentals have been carried over in its first issue, which is a really good start. There's lots of detail to work out, but in principle, it's going to be in there.
Good. Thanks, Derek. That's good to know. Malcolm DeBell, you've asked a very good question about how Tox and Fox get involved. Would you like to come up and ask your question, Malcolm? Sorry. Have we got Malcolm on, or am I? Oh,
no, apologies, I couldn't find the right button to click.
No worries, mate. About that.
Clearly, the Tox and the Fox are part of the whole system, and how are they involved in all this, Derek?
Yeah, and that's a really good question. It's something that we keep raising ourselves. You'll be pleased to know. The Venn diagram I showed which showed our primary focus was making changes to the fixed infrastructure, what they call capital delivery. You know, and historically, TOCs and FOCs are treated as back-end stakeholders, and there's a recognition that needs to change. So, because this has primarily been launched as an infrastructure framework, the tie-in is through one of the themes is operational and maintenance readiness. Now, that mainly gets into the TOCs and FOCs when it comes to station operations, to be honest, and the connection to TOCs and FOCs as, you know, service operators. It is there, but it's not direct. And that's one of the things when scaling it up from being purely infrastructure to, you know, infrastructure, timetable, train procurement, operations. It's at the industry level layer that the TOCs and FOCs become a really hardwired object in the system, and they're kind of less so at this level. And that's one of the things where it's really interesting working with some people like TFN on the best way to scale up to what we're trying to push the label of, is calling it industry level system integration, so that people are clear it's different from infrastructure project integration. So it's a really key point, man, one we shouldn't lose sight of through all of this.
That's lovely. Thanks very much.
Thank you, Malcolm. Thank you, Derek. I'll also ask a question from, got one from, it wasn't so much a question, I don't think, but Duncan Woods made a very good comment saying it's good to see the importance of language as a barrier, and how he's been a systems engineer for his whole career. He hasn't put time in.
Yeah.
So,
Yeah,
but he's never used so many of the terms that we had that we used on Monday. Duncan, do you want to elaborate on what I've said there? Sorry.
Hi, I think you've said it all, really, Carl. It's 35 years plus, by the way.
Bless you. Thank you.
Yeah, there's been a lot of discussion this week about different types of systems language, and I mean, I work in the aerospace industry, and I understand the language, and I've seen it before in various courses and stuff and events like this, but we don't generally use the same types of language in the real world, and it's good to see that that Network Rail using recognized simple language.
Thank you. Yeah, thank you, Duncan. Mike Moreau, you've got quite a detailed question. Do you want to come up and ask your question? Sorry.
Yeah, I could. One, I want to thank you, Derek, for mentioning my name so many times. But we'll have you back on the Nkosi Radio. Really. This was just about. I've worked on a couple projects already with Network Rail, and we deal with those in the R&D phase still that become generic applications or generic architectures, waiting to become applied to an application project. Where should SI4D play in this role, and should it be used early on, or should it be wait till later after they become more mature? What's the right way to play this?
That's a really good question. It's kind of, we're having that conversation now, kind of because SI4D is kind of locked in as a, if you like, bread and butter infrastructure project delivery tool. Mm-hmm. And we've got the digital rail program, we've got T190. There's lots of things going on that benefit from systems methods. We all know that. And I think the message we're giving internally, it is not simply take SI4D and apply it to an R&D project. It's not designed for, the principles are, those are all right, but the mechanics of it probably wouldn't really fit very well. And I think we've touched base with some of the digital project guys, kind of comparing notes at the moment to make sure we're not missing anything from each other, if you like. And I think what I'd like to see is that we have a clear identity of a systems framework for how Network want to do R&D, product development. We've got a very clear process for new and improved products with its own life cycle framework. So there is a systems approach there. And I think it'd be nice if we as a company can communicate it from the capital delivery, R&D, and the in-service system set. So when anyone is interacting with the rail industry or Network Rail, they know which flavor of it they're talking about. Yeah.
No, that's good. So I think it's helping as an enabler, but there's many forms out there that could be used to help shape it. But we're really, rather than following SI, we're enabling it so that when it becomes ready, a lot of the work's been
the other thing is
initiated.
Yeah, I think the other things become clearer, Mike, is that this framework, I think, it's essentially for a client buying changes to the railway.
Mhm.
So it's more about specification, assurance, and acceptance, and it is not a framework for. It's not the delivery system. It's not the development system. You know, so the supplier, the developer, is totally free to do it in the way that suits them.
Yes.
And that's be something I've been more conscious of starting to communicate that now than I was maybe last year.
The second thing is just on benefits, and we're tracking that early on in even some of these projects. That becomes important, but it also becomes important to do it in the right way. And how does SI, because that's really at a business level with Network Rail, is there a place for that within SI4D?
There is, but I think what you're saying, I agree. It is crucial. It links into things that are important to the people paying for it, or the people taking the pain in doing it. There's lots of metrics we can use. Over and above the easy ones, like who's accessing things, getting trained. I think at the moment we're relying on qualitative ones, where if, like, you know, senior directors and key stakeholders are saying, "I like that," that's a good enough metric to justify applying to the next one. If they're seeing, you know, if they're seeing and feeling it being helpful, then, and we all know how difficult it is to get some numbers on these in terms of cost risk reduction, schedule risk reduction, things like that. And we have introduced this SI gauge maturity benchmarking, which some of the regions are picking up and use as part of their periodic reporting as well. So it's a work in progress.
Okay. Yeah, I was putting in terms of like reaching CP6 goals and strategy and using that to help define it. I'm sure the route strategies have a similar near-term goals and how that links into the delivery of technologies and projects to help reach those.
Yeah, I think like a lot of big organizations, we could point to, for example, that process of using systems analysis to form next year's targets, next 5 years targets. That work is done. And we could look at that as a systems person and describe it as a systems framework. That doesn't mean to say we're saying it needs or would benefit from the application of this view to do it better.
Yeah.
So I don't know.
Thank you, mate. Thank you, Derek. Sorry, I know we will have to move on shortly, but can I just apologise? As I said, I'm using my iPad for various technical reasons, and I've already just noticed that a couple of people did have their hands up. I noticed Francis has put their hand down. Maybe I hope that means their question is answered. But Mark Bird, I noticed you've got your hand up and you've been waiting patiently. So Mark, if I could ask you to have the final question, and then we'll move on. Sorry, if you could be quick. Sorry, Mark.
Yeah, I do wait patiently because I know Derek can talk.
Back at you.
Michael's just stolen my thunder a bit because I was just going to ask about benefits. And certainly that's something we're looking at because I'm one of the few people who worked at industry level system integration, where we are talking to TOCs and FOCs and looking at performance all the time. But I was going to ask you, Derek, is there any plans to introduce the industry level system integration to your framework, or are you seeing it as somebody else's issue?
Right, personal opinion, we as an industry need to really come together and be clear about that piece. And we've talked about this many times, Mark. One option, if the SI4D thing achieves a really good branding, then it would make sense to have the industry level one as part of the shop for clients to understand how to buy it and for suppliers to understand what they're supplying. And this is where I know you do this an awful lot at your level, listening to our customers as to what's going to work for them in the way it's sold to them, the way we deliver it, and at what point you press the button on the analysis and actual systems, management of it. It is something I'm lots of conversations on. You're doing it. I've been doing a bit for another major program, and I think we've got cells of it going on. And I don't think collective in industry, we're totally there in terms of what the proposition is. I don't know if you agree, Mark.
I do agree. I think we're probably a few years behind the discussions you've been having about getting the industry to buy in that you need system integration, but taking it to industry system integration is a different level again. But it's no less important, because if you're trying to deliver benefits, then benefits is not just building bits of infrastructure, it's other bits that go with it. No, that's good. Thanks from me.
Thank you, Mark, and thank you as well, Derek. I'm afraid I think I better close it there because I need to get out other speakers get on. But Derek, if you could stay on the end, then if anyone's got any additional questions for Derek, please do stay on, and please feel post them in the chat. And If we don't get time for Derek to have a good chat, answer them at the end, we'll of course make sure he gets them, and we'll see if we can feed them back if that's okay. But Derek, thank you very much.
Thank you.
I give you a virtual round of applause. I appreciate you joining us today. Thank you very much. On our next to our next two speakers, we have a double act. We have Professor Clive Roberts and Dr. Heather Steele, both from the University of Birmingham. Thank you both for joining us today. Clive, as I'm sure many of you know, is the director of the rail research at Birmingham. And I think, in fact, you're the head of the whole School of Engineering now, aren't you, Clive? Am I right?
Yes, for my sins, yes.
Yeah, congratulations. I mean, I'm sure Clive needs very little introduction from many of us, as he's trained quite a lot of us, myself included, in terms of research and supporting us through our careers. Also joining him today is Heather, who has been doing rail research for 7 years now. And I hope someone's told her that she's never going to leave it now that she's in the railway industry. And she's has worked on many interesting projects all around simulation and modelling and data analytics. So very pleased to have you here today, Heather. Thank you very much. Exactly the right person we need to talk about this. And I'll hand it over to both of you now. Thank you very much for joining us today.
Thanks, Carl. As Carl says, this is a double bill between me and Heather. I'm going to bookend the presentation, so I'm going to start us off and I'll finish us off, and you'll have Heather in the middle. And we're going to talk about synthetic environments. This is quite an interesting topic in the industry at the moment. I guess we're talking about this in two senses. One is around a piece of work that we've done and has been reported within the T190 Plus project around synthetic environments and what they can do within in T190. If you don't know what T190 is, I'll tell you during the course of the presentation. But also we're talking about this area in general, in how can this area of synthetic environments, digital twins, simulations of simulations help us with that whole systems requirements process. So Heather's driving. So Heather, can you pass us on to the next slide? So I guess we could probably spend half an hour just talking and trying to define what a synthetic environment is. But I guess for the purposes of this presentation, we'll perhaps try and use this definition and say that this is a combination of models. So in our case, obviously a model of the railway network, simulation. So how does that work dynamically? We need to bring people into this, and people are using and analysing that data. And we're likely to bring real equipment in. So we end up with something that's a combination of hardware in the loop, digital twins, as I said, this simulation of simulation approaches, and we bring that together. And the key for us is that we end up with a representation of the real world that enables us to look and integrate things and understand what might happen in certain circumstances. And as you'll see on the next slide, we can use this in a number of places in the project lifecycle. So Carl mentioned a number of you have sat through my lectures. Apologies for that, but I think you won't have managed to sit through one of my lectures without seeing the V lifecycle. Really, just I think most of you know this, but just to quickly run through this. At that top left, what we're doing, we're at the early stages of the project, and at that stage, we're trying to work out what needs to be done and why we're doing it, capturing those requirements. Then as we come down into that lighter blue colour, we're trying to move from those requirements into a formal definition of the system design. So that's through the sort of specification phase into a final physical design. We're then building it, and then as we go back up the right-hand side of the V, we're testing individual subsystems, integrating them together and validating them, and then the bit perhaps you don't see on V diagrams very often is then this operational part, which is in our world, railways operating. And what I'm saying here and what we're going to talk about is how synthetic environments can be used to support that whole process. Firstly, to try and articulate what the problem is and what people need. And we've got experience at the university, and others in the industry have got experience of working with some of the greenfield railways. So HS2 in Birmingham, we're working with HS2, but we're also doing work in China with some of their new metros, looking at how can we use these sorts of techniques to understand both the business case and de-risk the implementation. I'm really keen to use these sorts of environments to make sure that we really understand the sensitivity fairly early on of key design parameters in the system. Then as we go through that system definition, really helping us using that synthetic environment to pin down the system definition. And the key part for what we're advocating here with synthetic environments is that this becomes a common golden thread through this process. So in the industry, we are doing this sort of stuff, but we generally do it in a start-stop manner. And maybe the customer is doing the first phases, the next phase is done by the supplier, somebody else is maybe doing the system realization, and then somebody else is doing the deployment and use. And what we're advocating here is that the same environment can be used throughout to provide this golden thread through a project lifecycle. And obviously just been talking about greenfield railways, we obviously don't have to be doing this with a greenfield railway. So then we're down into the system definition, which is really helping us ensure that we understand, as I said, those sensitivities, those key understandings of what we need to implement in the railway to ensure we meet the business case that we were talking about in the top left. And then really this is where the synthetic environment really comes into its own, is on the right hand side, is then the ability for us to be able to integrate that, what has up until that point been a model and simulation, into something that has hardware in the loop, is able to use use less testing on site in order to reduce costs, in order to ensure that that we can do better testing. We're very good in the rail industry of safety-based testing. We're not perhaps so great at performance-based testing, and how we understand which mix of things we do where, and what's best done virtually and what's best done on the side of the railway, either in traffic or between traffic. And then we move into the bit that really we're not doing very much at all in the industry, is using that common tool, that synthetic environment, to understand actual operational usage. And we know that the railway is not a fixed thing. We perhaps think of it as a fixed thing, but very often think that parts of the system change, making sure that we're using that continuous ability of the synthetic environment to model change as we go through the system. So we have this, as I say, golden thread that lies through the life cycle. There's one single tool, approach, or integration of tools is perhaps a better phrase, that is able to hang that all together for us and help us answer those early design questions around why we're doing stuff and understanding what it's for, then helping to understand the system design, then helping to understand the realization, and then the deployment and use. And then I guess the final thing around this, which is really quite interesting, is then the configuration management piece as well. If we have one single source of truth, which sits in this virtual world of the synthetic environment, we can use that to understand how the assets are deployed and keep the virtual model, the synthetic environment, up to date as one configuration management tool as well. So lots of power here. So if we look at the next slide, then this perhaps will help you give a bit of context. And it's certainly one of the areas we've been thinking about this project, this concept with, and that's with Network Rail Target 190 Plus. So for those of you who don't know what Target 190 Plus is, where have you been? But if you don't, this is a industry-run initiative supported very strongly by Network Rail, led by Network Rail. And the focus of this is part of what came out of the rail sector deal. And one strand of that is around how do we reduce the cost of signalling equivalent units, which at today's rate is £419,000 per unit rate. Over the next now 8 years, but when this was written, when it was the deal was done 10 years, so that we get ourselves down to 190k per signalling end unit rate. And there's a number of things that can be done in that space, but one of the big lumps of cost is around that right hand side of that V, around that test, verification, validation piece, and the fact that we, particularly on a live operational railway, on East Coast Main Line, West Coast Main Line, doing that on a live operational railway is incredibly expensive. It's actually incredibly time consuming as well. And how can we use the synthetic environments not necessarily, I think the words towards zero on-site testing are a good set of words here. How do we move towards zero on-site testing? So we're very intelligently doing smart testing on a live railway and everything else in a synthetic environment, in a specific integration laboratory somewhere. So if we go on to the next slide, we've done some work in this space supported by Network Rail. Under UKRIN, I lead what's called the UK Rail Research and Innovation Network, which brings together now 15 universities and 18 industrial partners, a network of collaboration around mid-level TRL, technology readiness level research and development. And this project was led by the University of Birmingham, but in collaboration with Atkins, Siemens and Thales. So very much a cross-industry activity supported by RIA as well. And we answered two questions in this space. One was, if the rail industry was to take up and proceed with synthetic environments, where is good practice? So that's the horizon scanning piece. Where should we be looking to understand how we do this? And remember what I said at the beginning, this is not just about technology, although technology is a very important part. It's also about how we do this with people and the processes. And I think one of the things we knew going into this work, but we definitely come out of this work knowing, was that those are equal parts. Technology is a strong enabler, but unless you put the people and processes in place to use this, then it won't be that useful. And that then fed into a second phase of the work, which was really about the feasibility. So coming up with a roadmap to implement this, and how do you do this in a multi-stakeholder industry where we have a number of key partners, obviously people like Network Rail, the suppliers, the train operating companies, all the other stakeholders that exist in the industry, so that we come through this approach with a unified answer, and something that is not a bespoke solution for one bit of the industry or one particular supplier, but something that would serve all and really make those cost savings that the industry is committed to through the sector deal. So I'm now going to pass over to Heather to tell you what we did in that study, and as I say, I'll pick up at the end.
Hello, can you hear me?
Yeah.
Yeah, brilliant. I wasn't sure whether it had unmuted itself then or not, so let me pick that back up. Sorry about that. Thank you for that introduction, Clive. As you say, I'll talk a bit more about the project that we did. You sort of stole my thunder a little bit talking about the research questions, but I'll plod on anyway. So within that horizon scanning piece, really wanted to understand what the current state of the rail industry is, and also to look at the state of the art in adjacent industries in terms of how synthetic environments are used and the benefits that they bring. Then in feasibility, considering how this can be applied to the rail industry to meet the objectives of the T190+ initiative. And finally, that roadmap development. So setting out a roadmap for developing the synthetic environment with milestones and clear outputs, so that we could articulate, achievable next steps to get those benefits in a timely manner. So firstly, we wanted to understand the current state of practice in the rail industry. And as Clive had said, that's not looking just at technology, but also people, information and process, which are so crucial to making sure that anything that is delivered is taken up, there's confidence in its outputs and that it's used to the best of its ability. So through case studies and conversations with project partners, we found some recurring issues that could be targeted through use of an appropriate synthetic environment. And I'm sure that a lot of this won't come as a surprise. So we found that although simulation-based processes, digital tools and technologies are being adopted and used within the industry, very successfully in some cases, but they're quite disparate and are not interconnected. And they're typically tailored for specific applications or projects, and they don't necessarily integrate with what's being used by Network Rail or other companies. So as Clive was saying, if you're handing a project over through the life cycle to different stakeholders, that the tools being used, that the models being used are different. Culturally, the industry and particularly those in charge of rollout programs can be averse to risk and change. And what we were told was that typically the way of introducing new initiatives is to sort of piggyback them onto existing projects. So you're looking at incremental change, and then those good processes or those tools only again being used within specific projects. Talking about how that information is threaded through the life cycle, how the industry uses and manages data is generally manually driven. So the same data might be collected multiple times for different users. It might be translated multiple times, and there isn't this single source of truth or a connected approach for how we think and use data across the whole industry. So there's a bit of inefficiency there that could benefit from having this created within a synthetic environment. And yeah, finally, that point that's already been mentioned, that there can be this disconnect in the life cycle of projects as they move from that initial specification phase through to development and delivery, and actually separation between what Network Rail do and what suppliers do. So that golden thread that Clive was talking about is missing. So of course these issues have been identified, and there's work ongoing to try and tackle some of these issues, which is really positive. So things like the consistent use of DAWs to manage requirements, or the Shift to Rail projects, various initiatives including X to Rail, which is looking at next generation testing and that shift towards zero on-site testing, and also capabilities being developed in the testing space. So testing, validation, verification, integration work being done by Network Rail, facilities like the ERTMS National Integration Facility and the Rail Innovation Development Centres, and then also university facilities at Birmingham and other Ukraine partner institutions. There's some of the case studies we looked at show that the rail industry is heading in the right direction. Some of the supplier tools and things like the Crossrail Integration Facility are really promising, but these are, again, they're separate initiatives. And the development of an industry accessible shared synthetic environment would really complement what's being done and pave the way to integrate the process, hopefully across the whole industry. So what can be achieved? Looking at the state of the art in adjacent industries, we firstly identified a number of industries with commonality with rail, in the sense that they're distributed, safety critical, and rely on digital control of assets. And we looked in particular at the 3 case studies there on the screen. So the Watchkeeper unmanned aircraft to support military operations, XBI's testbed to support the development of autonomous vehicles, and the Colregs validation toolset, which is about collision regulations for maritime autonomous vehicles as well. So we're drawing here on Thales's expertise and knowledge in these projects. And as we looked into what was being done in these industries in terms of simulation use, we found a lot of commonality between them and a lot of synergies between them in regards to the benefits that a synthetic environment can bring. And most importantly, sort of evidence that this can be done, and this is achievable when being applied to systems that are of a similar nature to rail. So within all of these industries, we found that simulation use is common, and the maturity of synthetic environments for specific applications is high, and that there's really a strategic approach to how they're used. So the use of simulation and its outputs is built into that life cycle from design through to testing, and that's all to support assurance, so it becomes part of the testing procedure. The value comes from the ability to test the design, the development, the integration, and the certification almost exclusively in the synthetic environment, so that real-world testing is reduced. And actually, in reality, for a lot of these systems, it wouldn't actually be practical to do all of the tests necessary for acceptance physically. Whether you could get 10 autonomous cars together to do tests of how they interact, and to be able to do that in all different weather conditions, for example, it's expensive, it's time consuming, and it's not necessarily possible to be able to do those tests. So having the synthetic environment and being able to run thousands of tests using automated scenario generation is really valuable, and it becomes an essential part of testing. And having the ability to virtually test at the early stages before much of the target hardware and software for the systems is available, and to be able to then feed that back into development helps to de-risk the rollout and integration of new technologies and processes in these projects. So that's another benefit. And again, as Clive mentioned, using the synthetic environment throughout the whole life cycle, that was happening within these industries as well. So the developed environments were adding value after the system's been deployed and in operation. For example, a modified version of the Watchkeeper synthetic environment was being used to support training on the system. So there is that benefit to be gained. In terms of feasibility, one of the key messages that came out is that what we're really looking at is integration and standardization, which is needed to be able to bring together these technologies, and not just technology, but information, processes and people, to create a synthetic environment that's capable of supporting projects through the life cycle. To get maximum benefit, it should be capable of connecting with other distinct design data and modelling tools, and there's a need for standards and interface specifications. And unfortunately, that standardization piece there are initiatives that are happening in the rail industry now. Also, in terms of feasibility, there's a whole wealth of best practice. We identified that could be drawn on and put into the heart of synthetic environment development. So looking at the adjacent industries, it should be said that they made wide use of commercial tools, and they weren't starting from scratch, and they were using the existing tools to build up capability within a couple of years. So this sort of does seem achievable within T190 plus timescales. And some of the things that facilitate reuse, scalability, portability, and accessibility of the environments are, open architectures, standard data exchange formats, interface specifications, and automation of data transfer. So those are key things that are really, really important to embed into the synthetic environment from the start. So ultimately, integration and standardization is really important to ensure feasibility and to get full benefit, and ultimately to make sure that we can capture, share, and visualize what's happening at different project stages for everybody involved in a project and a program. So that's the end of my bit. I can hand back over here to Clive to talk about a bit more about this golden thread. Thanks, Heather. So yes, we've talked through that high-level vision over the V diagram, and Heather's talked through the feasibility, the horizon scanning and feasibility work that we've done. But the key of it means what can this do for us? And the key is that we end up with something that is a data exchangeable format that shares the models, but shares those interfaces as well. It's worth pointing out that across this synthetic environment area, the interfaces and the architecture are really, really important. Getting ourselves through this simulated, emulated physical hardware and software sharing is really, really, really key as well. That moves us along significantly from where we are today towards that zero on-site testing and operational disruption, and that's really key if you think of projects like HS2, but also you think of the change in contractual nature, where suppliers are perhaps more vested and take more contractual risk in terms of the performance of assets in service. So we move to broadening out not just on safety testing, but in this performance testing as well. We need to keep the model up to date, but we only have one of those to do. It's the single sole source of truth, and we're able to use and this lends itself to using that systems engineering process, the kind of processes that Derek was talking about in terms of how we think about the industry and upgrading things and changing things. It fundamentally will force us into best systems engineering practice. So we end up with a process. The process bit's important, the people bit's important, and the technology bit's important. And if we just nip on to the next slide, Heather. So as I say, there's this whole mix of things together. They need to be integrated together. We need to think about how all of this works. And I've seen Carl appear, so I assume we're close to time. So let's move on to the next. So this work that we've done for Network Rail has actually initiated some
interest in terms of Network Rail moving forward to some kind of rollout of this technology. So we developed a roadmap for this as part of our study, and that's being taken on board, and Network Rail are moving forward with this in their T190 plan. So there is a set of sort of goals, and this shows the sort of time scale over a sort of 2-year period where lots of this capability can be developed. And we know from our feasibility and horizon scanning in other industries that this is possible and has been achieved elsewhere. And then just finally, I think, thank you very much, and time for questions. So thank you. Can I just say before I finish, tomorrow we are also speaking, it's myself and one of my colleagues, and showing you a little bit more hands-on, so it's more demonstration stuff tomorrow, showing some of the simulation stuff working and how that integrates together.
Thank you, Clive. That's much appreciated. Thank you, Heather. That was, I'll have to say, excellent presentation. As we've got quite a few questions coming in, we'll pick a few now and then maybe pick some more up at the end if we have time, of course, and pick any up at the moment. If we can start with Richard Jones, do you want to start with your question about test tracks? Okay.
Yeah, sure. Super. So thank you, Clive and Heather. That was really, really comprehensive, and I don't think anybody watching can think you're doing anything other than going along the right track there. So brilliant work. What about the role of linking to test tracks? I don't want to betray any commercial confidences of things I've been involved in, discussions I've been involved in, but I know you're interested in linking to test tracks to get real world data back to validate the model, because obviously if the model's not correct, then the results are going to be correct at the end of the day. How vital is that link to you? How important do you think that is?
Shall I start this up anyway? Yes. So test tracks play their role in this, as do pieces, particular assets in particular locations, as a hardware in the loop approach. So yes, at the moment we're not, as you know, Richard, and I guess it's probably the reason for the question. We're not using test tracks in that way, and we're not even designing really test tracks in that way. Although there are some sort of green shoots of hope in that area coming about at the moment. But where we can, and again, if you look at other sectors, they are using their equivalent of test tracks to do exactly this. So we use test tracks well and intelligently to both verify and validate the models, but also in order to put sort of hardware in the loop type activities. And it's worth just saying, again, this obviously is test tracks, but it's also big bits of testing equipment like rolling rigs and all those sorts of things can be used in that process as well.
Yeah, to pick up on Richard, definitely it's essential that the model is validated. You need to trust the simulation results and trust that they're right. And there's that issue of how do you abstract out complexity but still make it representative, and that's something that needs to be addressed when developing any model.
Good, thank you both. Thank you, and I certainly agree with using rigs like Harold, for example, to get real data back into situations, and it's a massively ambitious piece of hardware in the loop. Have you done anything with? Have you been talking to Bombardier about their Train Zero system?
Yes. Good. So that kind of thing. We have spoken to Bombardier about that, as you might imagine. Also, we have a cabs here at the university. One we developed ourselves, but one which is the Class 700 Siemens cab, the Moorgate train. And the idea there is to put back on, so that's the cab that was built, the mock-up that was built for the ergonomics study, but to put back on, or put onto that for the first time, the signalling equipment and various things, so that it thinks it's in the Moorgate tunnel as part of a simulation environment, and the passenger information system and the doors and various things are integrated in there, and therefore you can use that mix of simulation and real world, and you can actually have a human sat in there driving the train with a visualization in front, which we have that capability. But the signalling system is then operating on the train in the right way, and you know, potentially we have, for example, here traction rigs and things, so they're in a different room, but they could be then emulating the traction rigs on a live train as well. So that whole environment. We also have an approach to doing this distributed. So in that case, all of those things happen to be in our labs, but there's no reason why they needed to be. Yeah. You can actually distribute some of that. So, you know, there's bits of signaling equipment with a supplier. There's a traction motor with someone else. There's some limitations to that, but there is capability of doing that.
Yeah, fantastic. You mentioned people in a kind of a generic way, but of course, there you've just started to touch on the human interfaces, drivers, passengers, and so on, which is less predictable, less easy to simulate, but nevertheless has to be accounted for.
But certainly very much part of the whole system.
Thank you.
Brilliant. Thank you, Richard. Before, I know there's a few other people put things, but I noticed, Francis, you've got your hand up again. And I didn't get a chance to let you get your question in last time. So, Francis, if you'd like to come up, sorry.
Yeah, thank you so very much, and thanks, Heather. Thanks, Clive, for that presentation. It was very in depth and very interesting. Just drawing some experience that I have working in the aviation sector as well. There's also this drive in aviation to move towards zero physical test or limited physical testing and using these models as you go. But I was wondering if you maybe could elaborate or provide some thoughts on how you feel. Obviously, the biggest risk here, moving towards zero physical test, is the risk of not discovering your unknown unknowns. So issues that you may only find in the real physical environment. I was wondering what your thoughts were as you move towards less and less physical testing, how we, as an industry, that should be challenged to make sure that these are being considered, because obviously the model is only as good as those who programmed it and the data used to validate it.
Yeah, so there's lots of points to this. Obviously validation of the model, and validating the model for one usage doesn't necessarily mean it's valid for another usage. So there's that to consider, and is quite often forgotten in this space. Just because you have a good model for one application, it doesn't mean it's useful in other instances. But there's, again, ways of dealing with that. The key, I think, is perhaps to turn the word slightly differently, is to use the on-site testing intelligently. At the moment, we do a load of on-site testing, and there's some of those things that could be better done, and we could learn from on-site testing that feeds virtual testing and vice versa. Also, as we move to more latest equipment, latest technology, there's potential for equipment to test itself better than we had done, you know, when we were using mechanical relays and various other things. That's an important question in this space. And I guess one other thing is, can we actually argue that, I'm not saying this is true, I'm just saying there's an argument. There's an argument that by doing very specific one instance testing in the real world is not actually purely representative of the operation of the railway. And the alternative of that is actually doing millions of tests in a virtual environment, which does have that broader coverage of operation. So there's this mix of, can we take some very specific tests in the real world and augment those with virtual tests? And together we get much better than we do today. And I think the fundamental argument is lots of safety focused tests today, very little performance tests just because of time, cost, money. You can bring those two things together with the virtual world much more clearly, I think.
Thank you, Clive.
Yeah, definitely. Thanks for that. Yeah, definitely. I liked how you touched on there about the idea of using built-in test equipment as well, which is obviously an emerging factor to constantly monitor and provide feedback. So yeah, again, it's interesting to see the synergies between the two industries and how they're moving almost at the same pace towards this.
Indeed.
Excellent. Thank you, Francis. That was very useful, interesting. Thank you. I think we've got quite a few questions for you, Clive and Heather, but I think I'll have to leave some for the end. But I'll bring. If I could ask Stephen Bull, could you come up with your question? Because I think it's quite pertinent. And then I'm afraid Mike, Derek, and Arvinder, if I ask you guys to hold your questions until the end, and I'll come back to you. But Steve, if you could take your question, please. Thank you.
Yeah, thank you. I mean, very interesting presentation. Thank you very much. I think it sounds really exciting what we can do through synthetic environments. I was just struggling as I was listening to sort of contextualize it. I think to some extent, Clive, from what you said just now, you've sort of started to do that in terms of what the scope of the environments will be. But I wondered whether you can give any more sort of in terms of what it is you're expecting to include in that synthetic environment.
Yeah, so perhaps I'd start this quickly and then we'll put a bit more context around it. But I guess we're trying to ride two horses here, because we're trying to talk this in a philosophical sense as well as in quite a specific sense in what's being proceeded with T190 plus. So it's probably worth talking about T190 plus quickly. So in T190 plus, the intention is to look at how that cost of signalling can be reduced by using synthetic environments, and mainly, not entirely, but mainly on that right-hand side of the V. So how can we do, and if you think about the digitization of the rail network, actually, regardless of the cost, there isn't probably even the time to do some of the testing that we want to do on a live operational railway. So I'm not quite sure. Well, I would say, personally, I would say that lots of the planned upgrade programs are incredibly challenging, if not impossible, without something of this nature, because that's what's needed. So if you then stick to signalling, there's a whole set of things that can be done, and perhaps Heather, you talk a little bit around the sort of what's foreseen in this area.
Yeah, so definitely it's looking sort of predominantly at this signalling scheme renewal, so creating a new design. And one interesting aspect of this that we didn't necessarily touch on is the generic validation piece of saying that instead of creating a completely bespoke design for a re-signalling scheme, that you're using generic components, so you know what a BLIS does, or what part of that signalling CCS does and how it acts, and you can create that and put these generic components, whatever you want to call them, within a model, so that you're having a faster process for designing that scheme. Then as you've gone from that design through to developing the system, as Clive says, you're looking at software, you're looking at hardware, and suppliers actually saying, well, we have, to use the BLIS example, we have a BLIS and it acts like this, creating a software entity of it, but then actually putting in things like a physical copy of that to test within this environment, and looking at how that whole model works when you put trains through it and things like that. So it's a whole system model, but what we'd want to do is to get that down to component level testing as well, and then seeing how those systems interact. So I hope that contextualizes it a little bit for you.
Can I ask just one supplementary?
Very quickly, Steve. So
yeah, sorry. To what extent would that then allow you to take into account sort of the specific conditions of a particular piece of railway?
You mean in terms of track condition, or
track condition, gradient, weather conditions, that sort of thing?
Yeah, so that there are it really depends on how complex the model is, but you can certainly do gradient curvature. If you want to get into the detail of how track reacts in different weather, then there's sort of that level to it, but it depends on what complexity the model's going for. I imagine to start with, weather conditions aren't going to be top priority.
Okay, thank you very much.
Thank you, Steve. Thank you, Clive. Thank you, Heather. We actually have about 2 or 3 other questions that people would like to ask you. A bit of, you want to look at them in the chat, and if one or both of you is around later on, hopefully at the end we could pick some of those up in the networking at the end, because I think what they're all showing is there's some definite interest in this work, and definitely seeing the value of it. So thank you very much for coming to present it today. We look forward, Clive, to seeing the actual demonstration tomorrow as well. Thank you very much for that, for facilitating that. And Heather, thank you for being with us and presenting us today. I'll give you both another virtual round of applause.
Thank you, Carl.
I better move straight on now. Sorry to Andrew Simmons, who's putting his camera on ready. Thank you, Andrew. Sorry, thank you for being so patient. I think Andrew needs very little in the way of introduction. I'm sure many of you know him as the head of the Systems Authority within Network Rail, who have responsibility for Digital Railway Programme, among many other things. And he's going to talk us today about assurance and approvals, to see how we bring all this together and how we can get these things into operation. So, Andrew, I'll hand it over to you. Thank you very much.
Okay. Thank you very much. Just going to get my screen up. Just bear with me. Can you see that?
Yeah. Yeah, we can see that, Andrew. Thank you.
I'll just change into 2 seconds. Just change into presenter mode.
No worries, Matt. You just want to change your display, Matt, and then we're done.
Okay.
Yeah, we're in business.
Right, great, thank you. While I've been listening to those conversations from both Derek and on the synthetic environment, I've been tweaking my presentation a little bit just to make sure it all fits. So this is hot off the press. Just to give everybody a sort of an overview of what my role is as a system authority. One of those roles is actually heading up a section what we call the Digital CCS Guiding Body. And what this is trying to show you is there is a lot going on in this area, and from our perspective, there's a thing called a long-term deployment plan, which Clive sort of touched upon. That is what is driving us in terms of the need for cost reductions and a more efficient way of working compared to our conventional technologies. And just to give you a view, at the moment we're running about £400,000 per SEU on conventional technology. The base rate at the moment for ETCS schemes, without any of these efficiencies, is around about 315, and the sustainable rate is somewhere around about £190,000 per SEU. So that gives you the scale of the challenge from where we are now through to where we want to get to. And we're looking at the whole life cycle of delivering a signalling scheme. So T190, as mentioned by Clive, is looking at the whole life cycle from procurement, supplier engagement, supplier incentives, right through to, as I mentioned there, testing and commissioning on the ground. And quite clearly, what we just mentioned there, synthetic environment, is a key element in reducing those times. And the cost savings we believe we can get mainly from elimination of time. The products are going to be fairly much as they are today, but it's elimination of time and process that's really going to make the change, and hence the need for synthetic environment. So you're going to say, what's that going to do with assurance and the like? Well, let me just explain basically that if you don't get the assurance right at the end, and Derek mentioned this, you can have unforeseen circumstances in your projects, and therefore that can lead to time delays and overrun of costs. And that is something we just really want to try and drive out. So we've actually started from the end, as you know. In other words, we want to get systems in operation. What do we have to do in terms of authorizations and assurance processes to make sure that this is repetitive and with low risk? That's our challenge, really, I think, as an industry, to do this time and time again. And I will back up what Clive said. There are some really complex schemes coming up in the next control period that we've got to consider. However, we do have a number of constraints. We just can't think of anything. We have to comply with certain things. Since Brexit, of course, we've got NTSNs, NTRs. We've got ops concepts of how the industry thinks it wants to operate these systems. Business requirements. Each scheme will need to have a business requirement. Perhaps very, very importantly, again, coming back to synthetic environment and some of the stuff that Derek mentioned, business change. How are we going to migrate our people and processes into this new technology? So they're the inputs, as it were. So what we're trying to recognise, though, is that the only people actually who can put this into service are the duty holders. It's their accountability, nobody else's. They need to go through this process, and they need to convince themselves that they've performed integration, going back to Derek's slides. And therefore, at an industry level, we need to be able to demonstrate integration. And that is a challenge for the industry as it's set up at the moment. But for the digital railway programme, or and future CCS programmes, we have to address that problem, because the systems are split across track and train. So fundamentally, the TOCs and the FOCs and Network Rail regions are the only people who really have to sort of make sure that they can work together. Now, when we come to, you'll see in a minute that the ROGS regulations actually provide for that activity, and they're very, very good in providing the framework for this integration to occur. It already occurs at what we would call safe integration. You will see that much of the other performance integration, if you get the safe integration right, safety and performance goes hand in hand, and you get a lot of the benefits. So a lot of people also get confused with, in terms of whether it's authorization and interoperability plays. It's just part of this process, which you'll see in a future slide. So what we decided to do as part of the sort of like the Future CCS Digital Railway Programme was to actually try and allow those duty holders to follow their existing processes. We didn't want to invent anything new. We wanted them to be able to use their process. So for Network Rail, for instance, it would be grip or speed. It would be a process you get a set of requirements, and they really need to be able to demonstrate that they've actually achieved those requirements. Now, for this to work, quite clearly, you must have a very, very good set of requirements. Going back to what Clive has said, the left-hand side has got to be very, very clear that you've got a set of requirements that, if delivered, can provide you with safe integration at the end. So part of what the Digital Railway Programme set out to do, and part of the System Authority activity, is to generate those requirements that will provide a system that is fit for use for its intended use and can comply with legislation. And that's really it in a nutshell. So the way it's been approached at the moment is through looking at use cases of how we operate the railway, looking at how the technology could influence those use cases, and then coming up with a set of technical requirements, a set of operational and technical requirements, and how we would then migrate those into the industry. That's the challenge that we've been setting ourselves, and the first standards, albeit they will need some changes as we integrate the two systems together. So to make sure that we've got these requirements correct, I've put there generic testing and simulation. So as part of our synthetic environment suite, or ecosystem as we're calling it now, Network Rail is actually in the process of securing a process and systems to be able for us to generically test those requirements in a simulated environment, such that we've got confidence and we can validate that when they're put onto the live railway, there's a good chance that they'll operate as intended. That process is already ongoing, so we're already procuring that in advance of some of the synthetic environments that Clive and Heather were talking about. Having produced these requirements, we really need to have a sort of like an independent review to make sure that the processes we said we would entail to produce those requirements we've followed. So we have an independent system body that basically looks at the way our processes work. That's both my process within my team, as a system authority, and also the SR&I team who are actually producing the requirements. So basically, we provide information to this system board to provide them with information to say this is what we said we were going to do, and the requirement suites do meet those requirements. Now, this board, though, has no real meaning because it comes back to the duty holders. So what they should do is provide support to the duty holders to say they've reviewed our information and they're confident that the code of practices or the standards that we're producing are fit for purpose for their intended use, and they should be able to put them into their own risk assessments, which I'll come on to in a minute. So that's where we're doing with the process at the moment. We're trying to front load the validation to generic level, such that there's a minimum bespokeness, as it were, on the integration at the right hand side. When we've actually achieved a couple of projects, 2 or 3 projects, and the intent is that those requirements that we'll be using, we would present them to the RSSB standards committees, and then if they're comfortable with the process that we've run and the evidence is all there, then they will become RSSB standards or RISs, and therefore what will be required then is to use these codes of practice as approach. So that's sort of where we set out to do it. But what we realised that this is only really one part of the element, and we really wanted to make sure that the whole end-to-end process of assurance was laid out, such that the ROSCOs, the FOX, the TOCs, and Network Rail were able to understand what their requirements were under the legislation. Now, I cribbed this slide from a presentation given by RSSB. So if any issues with it, go to the RSSB. No, I'm joking. I modified it. Hopefully, this is also post-Brexit compliant. If anybody can notice anything in there that I've missed from converting it from a pre-Brexit to a post-Brexit, then please let me know. But fundamentally, the issue that we've got to worry about is putting into use. And the only legislation that puts into use is ROGS. And the way that's managed is that each individual duty holder has that requirement to follow ROGS in their safety management system. And part of that is they must carry out a risk assessment and with other duty holders carry out duty of cooperation. That has to be carried out for every project. And Derek mentioned there on his triage, you determine how much of that process that you have to carry out. On very complex projects, you almost have to start from the very beginning, from risk assessments through to very simple subjects where potentially you have a template already in place and you can just pick up and follow the code of practice approach. So effectively, that's the main thing. So working backwards from ROGS, one of the things that we have to do in the ETCS world is then work out the root compatibility or train compatibility. That really is covered by an existing RIS 8270. It covers things such as EMC Engage. It's technical compatibility. It's not the same as system compatibility. That system compatibility also needs to know that it can be maintained safely. The rules are in place. So if you like, it feeds into that and into that put into use. Then we come into authorization. And authorization really is just a stage in this process to say that I have got some products that are compliant with the standard effectively. And the way that works is obviously, I'm going to go to the left-hand side now. We have a set of NTSNs in this country now. And that what we have to demonstrate is that the project at authorization stage meets the essential requirements of health, environment, accessibility, technical compliance and reliability. And the bit that's often missed is the technical compliance and safety. On safety, at the authorization stage, you must be able to demonstrate that the system is capable of being safely integrated into the railway. Yeah, so it has the capability. You don't have to demonstrate at that stage that it will be integrated, because that comes later in the put into use. But the issue is, if you don't do that integration at the first part, in other words, demonstrate that it is capable, and the poor person at the back end of it, who's sometimes different from the project entity, has got one real task in trying to demonstrate that their system is actually capable and can be demonstrated to be safe into operation. That flowchart really is the heart of the assurance process and your authorization for the duty holders. It doesn't matter if it's Network Rail, is putting it into use, or is it sort of like the person who's making the change, or whether it's a train operating company. That process is fairly well defined. So just to sort of try and see what we're trying to do here, again, to simplify the process and put as much as we can up front. If we have a look at what you need to do for ROGS compliance, you need to do the system definition, the significance test, the hazard analysis, all those issues there you can see in that ellipse. Very much what Derek mentioned in his presentation. So if you're a railway undertaking and you wanted to put a new train fitted with level NTs with ETCS equipment in there, you really do have to have a safety case that's a safe integration, that you know how to operate that train in with its new modes on the existing railway. So you will need to have for instance, as an example, you will need to have different competencies of the drivers to be input into the DMI, and also different competencies from the drivers, what not to do on the DMI to lead to an unsafe case. So there has to be some form of assessment carried out. Now that's not going to be different between each operator. So you could come up with a template for that. In achieving that, there should be a duty of cooperation from that railway undertaking to make sure that they've consulted with Network Rail and that their safety management system does dovetail into Network Rail safety management system, and collectively that there's no risk underlying on the railway. Now, typically, it will be Network Rail who then will do the change of the infrastructure, always, and they will normally be the reason why it's changing. So they'll be the change agent. The Network Rail will then have to obviously demonstrate ROGS compliance for the changes that they're making. And that will require duty of cooperation with the railway undertakings to make sure that those undertakings have got all the right management processes in place to be able to operate their trains safely, in this case, in ETCS level 2 overlay area. They've got the right training, they've got the right equipment, etc., and they know how to run it. Similarly, Network Rail could then put in a no signals area, and the same thing applies, duty of cooperation. And what you're seeing here is we're building up potentially a library. I know Derek mentioned the word as well. And so we've got a number of variants here in different geographical areas. And what we're suggesting happens is that effectively the digital railway programme, which I showed you earlier on slide 1, producing the requirements, provides inputs into those ROGS compliances. So effectively, when you go through your risk assessment, what we're intending to want to do is for those particular duty holders to be able to pick up the requirements from the work that's been done by the digital railway programme and use those as the elements to control risk and hazards. So that's what we're going to try and do. And you'll see there that within those system requirements, we do have a thing called a test yard. So what, again, going back into the simulated environment idea, these will be tested on the test yard. So we've got confidence that all the requirements of the system have been identified in the test yard, tested once generically, and we're comfortable that it works. So any of these other ones should be subsystems. Probably not explain myself here, will I? So effectively, what the line manager will have is a library of ROGS compliance templates, and the railway undertaking will have a list of ROGS compliance templates as well. And eventually, what we can do, of course, then is that this library can then be built up, and therefore, if a project, say for instance, this was done on East Coast Main Line, because they've done it once, we'll remove the geographic area and we'll just say, right, okay, we can reuse this template on the West Coast Main Line if the system definitions are aligned. And that's the crucial bit, is getting the system definitions. And Derek mentioned that again, context diagrams, all those good stuff help you be able to make sure that your system definitions are aligned. Similar for railway interoperability compliance, what we have to do there, I mentioned before, essential requirements need to be satisfied, compliance with the NTSNs and NTRs, the ability to be safely integrated into the operational environment, approval by the approved body, the DBO or the ASBO, a declaration of verification, and a safety authority authorisation is required. To make that work, the DR programme have come up with these set of requirements. The particular project, like the ETCS overlay, what we're aiming to do is go for a test yard compliance, using the synthetic environment, using the test yard and a test track to get compliance for a typical overlay scheme. So manufacturer A would then have to demonstrate that their equipment can work on the test yard and or the test track. They'll get equivalent to a type approval for the infrastructure, and then with the process, a quality process, we can then apply that multiple times. So you don't have to go for authorization at every stage. You just do it once for an overlay configuration based upon the test yard in the virtual environment and RIDIC. Similarly, would occur for no signals railway and for a hybrid level 3 railway. For rolling stock, it's pretty much the same. So most rolling stock will go for a type authorization, and then they'll use a fleet fitment for a process. What we do have, though, for interoperability reasons, is this thing introduced called ERTMS system compatibility checks. And one of the areas that we need to do is define what the area of use is. So we're defining a load of ESC checks, as it were, for each of these areas. And what we're saying is that at the time that our infrastructure is authorised, it should be able to operate anywhere within the UK. So we'll get generic approval. It just won't be King's Cross or anything like that. It will be for the whole of the UK. And the safe integration checks coming out of the ROGS process in terms of checking to make sure that the system can be safely integrated will also be carried out at the authorization stage. So that will demonstrate that it can be safely integrated. And all this data would be put into RIMF, which is the railway, which is the infrastructure data, such that everybody knows what part of the UK is this area of use. Such that if you go and buy a new rolling stock, then you can check before you buy that your system what it's required to do. Critical factor of all this, though, is that, and Clive mentioned it, is actually change control. If we get these templates set up, they won't necessarily, from day one, they won't be 100% complete, and there will be variants. So what we're trying to do is make sure that there is a system change control on these library of activities, such that we're all comfortable to say if the test yard needs changing because there's a new feature, then we would expect to reauthorize that particular product against that new test yard as and when it's required. So system authority of providing the change control for that to make sure that as an industry we don't lose divergence from operability on the ground. And similarly, what we get to is that we will have these libraries of checks and the like. And lastly, for ROGS, of course, the same thing applies. If we're going to have these templates that we're changing, then the templates themselves will also have to have system authority change control. So very much what Derek said there is aligned with what we're trying to achieve. Just to put this in perspective, we set this process up, started about 2016, and you can see there how you can go through the testing processes, starting in the factory with the product, then integrating it on the left-hand side of the rolling stock, then integrating it onto the train, checking that the train does its thing against the reference design, putting on the dynamic test track at ENIF or RIDIC, and then making sure that the train actually does perform as intended. So therefore, at the end of it, you've got a pretty clear indication that you have a train that's fit for purpose. Certainly on the right-hand side, we would expect that the supplier testing would demonstrate that the RBCs or whatever are correct. We would then do the test yard testing, the interlocking interface, that's with the test yard, and eventually then we would test it on the test. The RIDIC part would then demonstrate that the trackside components are all working together, and then we interface it onto the track. Now, the real important part here is that the INIF lab we've got there and the INIF test track very much is aligned with what Clive and Heather mentioned in terms of the synthetic environment. That's the target area that we're looking at in terms of reducing the time spent doing those activities. And lastly, then, this is where the synthetic environment development opportunity and challenge comes in. How do we make sure that we can tie in T190 plus program, network rail regions, the sector deal, supply chain, all together to make all these come together with the aim of reducing the unit rate from about 315k per SEU on ETCS at the present time to something sub 190k per SEU. And that's the challenge that we're looking at. There's a massive opportunity. All I think I've highlighted there is that the framework is already in place with the duty holders to do that. So that process I've just showed you through there has been agreed or has been agreed as best you can with the regulator, and they're comfortable with that approach. So the framework's in place for synthetic environment. The framework's in place for generic requirements and the way that Derek explained the way that we're looking at it from a sort of like an integrated approach. So hopefully that's it. I've made some time up there for you as well.
Thanks, Andrew. Much appreciated. Yeah, sorry about running a bit over at the moment, everyone. But as you can, I'm sure you mentioned that we had some very interesting discussions there. I noticed we haven't seen anything in the chat. Has anyone got any immediate questions for Andrew on that on that assurance process, or how synthetic environments and test labs are going to be used? Anyone want to raise their hand or just chip in?
What I can say, Carl, while we're waiting, yeah. Yeah, one of the things that we had to say, we've been working I mean, as part of my role now, I'm a sort of like client for T190, and the sort of the whole thing is dovetailing together. And I think it's fair to say that what we haven't sort of identified here is where enterprise architecture fits in this as well, in terms of trying to define, what the business models are. And so we're using that overarching all of this to make sure that we get our requirements right at the first stage. And if you get those requirements right, I think it was Clive or Derek mentioned it, you don't want to go and rework it. So going back to this client's this capture process, requirements capture, really important issue.
Fair enough. Yeah, good point. Thank you, Andrew. Mike, you had your hand up first. Do you want to raise just a quick question, and then Derek will give you a go as well?
Hello, Andrew. Yeah, very good. Well covered. I remember that well from 2016 and how it's developed over time. My question is I've seen this type of thing done in defense as well, and synthetic environments are very complex. They're a key enabler, but they're almost a program in themselves to mature them in a way that serves other things. How is that being done programmatically in Network Rail?
It's a great question, actually, Michael. Yeah, we've read. I mean, following the University of Birmingham report, we've had some soul searching, I think, within T190 program itself. Yeah, and what we are looking at, and it's an ongoing process at the moment. We're looking at changing the structure of T190 program to sort of deliver the synthetic environment and ecosystem, as it were, as a sort of like absolutely a sort of dedicated team to run that process. At the moment, so now we understand what the scale of this challenge is, and so we're looking at say it's going through change control to change this program at the moment, but we are looking at a dedicated program team, dedicated technical team. They're not experts, because we came to the conclusion there isn't one expert probably anywhere in the world who's got both synthetic environment and a sort of skill set and a sort of future CCS skill set. So we see it's working collaboratively with industry partners to provide this element. So we are hoping to go out to tender later this year against sort of like almost like a delivery partner to work with us in that development program. So you have Network Rail Core sort of program managing it and providing the main knowledge from the railways, but also hopefully with a partner who can provide the domain knowledge of how the processes work, and like Heather said, to work collectively together to try and pull that together. So we've really taken on board what's been said in the University of Birmingham report. Things such as innovation frameworks is what we're looking at.
Brilliant.
All right, thank you.
Thank you, Andrew. Derek, you had your hand up as well, sorry. Did you want to bring in?
Yeah, thanks, Andrew. That was really comprehensive, that. Thank you. You really got me thinking. I think between what you talked about and Clive and Heather were talking about, and we heard Mark Burton, we've got some really solid bits of work being done. Lots of different volume going on between your work on like T190 Digital Rail, if you like, the area I talked about, which is what I was calling bread and butter, making changes to the railway in the old project environment, and knew it. Then this kind of new area of industry system integration to coordinate trains, operations, timetables, infrastructure together. We seem very comfortable there's alignment, because I think there is. And in the past, the industry would probably try and hardwire it all together to make a perfect statement how it's going to be done. Do you have a view on whether that's possible, and whether we should keep the push in terms of pushing on people's behaviours, collaboration, and working out the right integration method for each instance of where we need to come together, if you understand what I mean?
Yeah, no, yeah, yes, yes, and yes, Derek. And it's interesting. This is my role as system authority. I applied by Network Rail. It's very outward looking in terms of talking with the train operators and freight operating companies. Yeah, very much so. And we hear all the criticisms, and it's really quite interesting when you sort of sit in the middle and you look back at your own organisation and say, "Yep, I agree with you." But I would say is that the East Coast Deployment Project. I mean, they are looking very much as it being a user sort of like led sort of process, and they are coming up with some challenges, I would say. They are challenging in a few areas. And indeed, I think Clive mentioned that they're looking at the Moorgate branch and whatnot. The way that they're now attacking the Moorgate branch in terms of the migration is probably different from where you'd come up with it for an engineering solution. When you put the operational concept in there, it does change. Yeah. I think what we're good at as an industry at the moment is probably defining what the end state looks like, because that's where we started from. There are some massive migration challenges which are huge in themselves, and somewhere in there you also recognise, and going back to what Clive said, there is this synthetic environment element where we think we can make business change a lot simpler for all concerned if we have that capability. So a lot of the benefits we see are on the left hand side as well as the right hand side, as Clive mentioned, but the big challenges at a system level are with people at cross industry level, and hopefully the process that we've laid out, we've involved industry all the way.
Okay.
Thank you.
Thank you, Derek. Thank you, Andrew. Andrew, if I could just say thank you very much again. I'll give you your round of applause and say thank you very much for presenting. I know there's a couple of other questions that are coming through now, and which I will pick up, but I'd like to give our two elevator pitches their time in the spotlight just now. So thank you again, Andrew, for this time. Hopefully we can pick up some more questions afterwards and feed any others that we have to you. I hope it'll be interesting. Paul and Stuart, if it's okay with you both, if you both, I can put your cameras on for a moment. I will introduce each of you, and if you could each give your pitch, and then what we'll do is we'll save questions for after you've both done your pitches, if that's okay, and do that as part of the wider discussion at the end. So I will start by, if I could start by introducing Paul Whitcomb from Harmonix. Who's their transport managing consultant and account manager. I've got that right, haven't I, Paul? Yeah. And you can talk about your business, and then after that we'll have Stuart Gibley, and I'll talking about SEMP, but I'll give you a little introduction, Stuart, after this. So Paul, if you'd like to take it away, please, Matt.
Yeah, thank you. Second, sorry, I'm having a difficulty with my laptop. Hopefully you can see that now. Right. Okay, thank you, Carl. Thanks for that. So I work for a company called Harmonic. I'm going to take you through this presentation, but first of all, I'd like to take you through a quick video. So 1 second. Okay, so I'd like to expand on the video you've just seen. Harmonic is a delivery partner. What I mean by this is that we improve program delivery by integrating into our customers' teams. We move quickly and effectively to understand challenges, improve ways of working, and embed our teams to deliver joint outcomes. We leave an enduring capability and are confident in our service so much that we stand behind it through different commercial mechanisms, including a risk-reward approach, where we'll put an element of our fee against the outcome required. By doing this, we align ourselves with our customers and bet on the joint team. This is possible as we have developed an effective end-to-end approach called Transformation Workflow. This is a way of working that combines business winning, project, technical management, systems engineering, culture and people capabilities to successfully deliver the required outcomes. By covering all these capabilities, the team can work effectively, understand and deliver issues quickly, and support with the right capabilities and improve performance and outcomes. One of the things we are pleased to say is that we've signed up to the Equality, Diversity, Inclusion Charter. This is something we feel is very important to our people and our business, because our people are our business. And also the last thing, at the last RIA event, we enabled an interview with Charlie Duke Jr. One of my colleagues knows Charlie personally, and we've been gleaning insight from him as NASA was the birthplace of systems engineering and complex project delivery. Two things that Harmonic have in common. So where programs fail. So Harmonic has been working in the rail industry for the past 6 years on various programs. We have over the period seen several issues through the life cycle of delivery, and I'm sure you'll recognise a number of them. So this graphic shows at a very high level project delivery, shows the key stages. The flags identify the cause of problems at the stages. As you can see, there are only a few areas of problems. Through this graphic, it shows that at different stages of the program, there are problems or errors where things are not defined. This is where systems engineering combined with project delivery in a delivery approach can help. We have been on projects where the requirements were identified, the program started. Through the program were issues and delays because interfaces weren't thought through, or suppliers' contracts didn't quite align with the program. Even the testing can be defined, but only to test the product, not the interactions with other systems. The outcomes meets what is asked for, but not really what actually is needed. Through our transformation workflow and integrating business winning, project technical management, systems engineering, culture and people practices, these programs can be delivered to budget timescales and get to the outcome that actually is needed. Harmonics was established in 2003. We're an SME with a variety of large customers across several sectors. These are a handful of these companies. Thank you very much.
Fantastic. Thank you very much, Paul. Stuart, if you'd like to come up now. Stuart is with is from SEMP Limited. He graduated in the 90s with a master's in electroacoustics and started with Westinghouse in 2003 and has had numerous systems roles within London Underground and Network Rail. He co-founded SEMP in 2015, and as well as he's a chartered engineer and on the UK Incorsi Advisory Board. So, Stuart, please introduce us to SEMP. Thank you.
Thanks for that introduction, Carl, and thank you to RIA for giving us the opportunity to just quickly give you a bit of an intro to the company and how we've been applying a systems approach to rail infrastructure projects. So I'm Stuart Gilby, I'm a director of SEMP. The company was established in 2015 with a mission to transform the performance of infrastructure projects by applying a systems approach to delivery. And we passionately believe and continually demonstrate that many of the issues related to the delivery of complex projects can be reduced or solved by following a systems approach. So we're solely dedicated to systems engineering for infrastructure projects. 90% of our work is in rail, although we're increasingly asked to support other industries. We partner with infrastructure owners such as Network Rail, Metrolinx and Queensland, and delivery organisations like construction consortia and tier 1 engineering services providers. Currently delivering projects in the UK, Canada and Australia, and are just about to start work in the US as well. So there are 4 key challenges we sort of regularly encounter in support. and we've heard a lot of these mentioned during the presentations today. The first is around achieving the desired outcomes, and that's in terms of identifying the right interventions to deliver capability improvements to the operational railway, defining the required outcomes, and importantly, protecting the realisation of those benefits throughout delivery. Secondly, integration, and not just managing the interrelationships between parts of the system, but in planning and executing the delivery of multiple overlapping large complex interventions to the railway, especially operational railways. Third, confidence in delivery and increasing the probability of successful delivery, time, cost and performance. And we achieve this through removing risk early and implementing a right-sized assurance process, which progressively builds confidence. And we use data and dashboards to provide actionable insights, which enable the decision makers to make informed decisions and target resolution to issues. And lastly, around the capability for organisations to deliver. So about building the skills, experience and capacity to deliver the approach. And experience in the rail domain is essential to get maximum benefit from applying that approach. And we can't overstate the importance of all the people and organisations involved in the delivery of at the very least having an awareness of that systems approach. But this is also about implementing the structure and the governance arrangements and the commercial model to support that successful delivery. So in terms of developing our approach, sort of a quick history, the directors originally started in systems engineering, defence and aerospace. And from 2003, we've been applying that knowledge to various rail projects in the UK, forming the company in 2015. And some real world examples of where we've applied that framework. So Transpennine route upgrade, we generated the client and programme requirements and apportioned those down to the delivery alliances, supporting option selection. And we're now in the process of assessing the V&V and compliance submissions coming back from those alliances. And I thought I'd give you an overview of some of the projects we've been doing in terms of exporting that capability abroad. So in 2017, we were asked to get involved in the Confederation Line, which is an LRT in Ottawa, at the test and commissioning phase. And we demonstrated compliance to 10,000 technical requirements. We built the safety and assurance case and ultimately signed the safety certificate to enable that line to go into revenue service. We performed a benefits assessment for another light rail transit in Toronto this time, which is the Finch West LRT. And that was about identifying the benefits for that scheme, tracing them into the two primary contracts and identifying gaps and risk with the delivery of those benefits. Moving on to 2019, Metrolinx in Toronto are currently embarking on a major upgrade to transform the regional railway in around the Greater Toronto area. And we were invited to incorporate the application of 50126 and progressive assurance into the safety schedule for the programme they were developing. And we also edited the Canadian version of the Common Safety Method, incorporating our lessons learned from applying CSM in the UK and Europe. And more recently, Toronto's Union Station enhancement, we performed all of the systems engineering and assurance activities up to concept design to enable the client to have confidence in moving forward to the delivery stage of that project. And as we've gone through that journey, we've continually refined the process that we apply. And we're now focused on ways to improve the awareness in the implementation of the approach and in accessibility of the data across the wider enterprise. And I thought I'd just finish with an observation on where the industry is heading. Certainly over the last 1 or 2 years, we've noticed a shift. So we always used to be asked, why do I need to do systems engineering? What are the benefits? And there was that difficult selling job that Derek was talking about as well, and how difficult that is. That's now being replaced by, I understand the benefits and I can see the value in the approach, but how do I best implement that approach within the organisation, within the project, to get maximum value and deliver the benefits to the project? So that's a really positive shift that we're seeing, and that's especially happening in North America as well at the moment. So thank you very much for listening. Happy to take questions, or please feel free to contact me if you'd like to hear more about any of those experiences. Thanks again.
Thank you, Stuart. Thank you very much. If you could, if you would like to keep your video on, if Paul, if you'd like to put yours on, and if any of the other speakers and presenters who are still on and would like to and are staying on, please do are able to stay on. Please put your cameras and speakers back on. First of all, can I thank you all again today for your presentation. I'll do the wrap up in a bit, but if I could just ask, does anyone have any questions, first of all, for Paul and Stuart? If not, we can go back and pick up some of the other questions that we haven't had a chance to get asked yet, which particularly for, it looks like, unfortunately, Clive and Heather haven't been able to oh, no, sorry, Clive, there you are, sorry, because I know there's a few for you, Clive, and Derek, there's a couple more still for you, your good self as well. So, but does anyone want to ask Stuart or Paul anything about their businesses, or would you rather take those offline where you can have private chats? If anyone wants to, sorry, Andrew.
Yeah, so Stuart, yeah, it's good to see that it's developed from when we worked together with you. So congratulations on expanding that, and good luck for the future as well. Then.
Thank you.
Thank you, Andrew. That's very. Thank you for that, Andrew. That's really good. Okay, I think we could probably. I'll just mention that tomorrow the event will of course be continuing. And we're going to change things up a bit, as Clive mentioned earlier, because we're going to have some demonstrations tomorrow of modelling and simulation tools, including the one that Clive and Heather were talking about, and we're also going to have another example of a synthetic environment that HS1 have produced, which looks more like civil engineering and station development, as well as Fraser Nash Consultancy's depot modelling tool, and also we've got the National College of Advanced Transportation and Infrastructure coming in to talk about some of the, to show some of the tools that they're teaching their students, which will be good. Which, of course, Clive, I know you have an interest in there as well. So, yeah.
It's now part of us, yes.
They're now part of you, aren't they? Yes. I thought I'd have, both sides of the training going forward. So that's good. Thank you. I'll keep the call open, like I say, until 4:30. If we'd like to, and if it's okay, I'll go through some of the other questions, because there were some very good questions here, and if nothing else, it'd be good to have them on the recording. Derek, if I can come back to you, I don't know if Stephen Bull is still on the call, but he asked the question when you were on about what he's seen of SI4D defines a triage path and development path for individual disciplines, but he didn't remember seeing any guidance for overall integration and the trade-off between the disciplines. For example, the conflicts between safety and security, or between safety and reliability. What does it? Can you tell us what SID offers to support trade-off between these disciplines, or has it been considered yet?
Yeah, no, I read that, and it's this goes to the framework being about a framework to product to understand what it's taking on, and without trying to overwrite or change or meddle with, if you like, the rich picture of complex processes that already go on. So there's either the simplest ones, ad hoc trade-offs that go on. You know, a theme activity might be simulation modeling, it might be hazard analysis, it might be some ground investigations. Kick off something which conflicts an assumption and kicks off if you like, an organic process of the project reconsidering things. And if we go up the levels of system hierarchy, we've got the business case process, the investment decision framework. And I think that's the bigger loop of trade-off, where if a project is coming back with a solution that works, but conflicts with some other key requirements, then I think the big trade-off loop, really, when we're as systems people, is it goes back to the business case loop with the system operator and people like that. I've seen various islands of a trade-off process in different disciplines and activities, but it'd be wrong to claim we've got a unified, simple, this is how we do trade-offs in the rail industry. I don't know if other people agree or disagree.
I think anyone want to comment on that or take a view on that? It might be one that we need to have a wider discussion on at some point, Derek, because it's a very good point. I think, like you said,
it's a good point. But but the framework doesn't constrain in any way how to do the trade-off. It just makes sure a decision is taken that enables a project to move forward.
Which, of course, must be done. Oh, excellent. Thank you, Derek. That's good. Since you're speaking, Derek, I know you had a point when Clive and Heather were speaking, asking about the size of effort involved in the implementation of the wider scale. I don't know if you want to of such a synthetic environment. I don't know if you want to bring that one up.
Really, just work. The opportunities are clearly massive, and based on my experience of a much smaller, if you like, change with our system integration framework was treating the population of the rail industry as part of your system when it comes to creating the capability to do this at scale, en masse, and this great end game of having a live synthetic environment which is always up to date and is maintained and is valid. The roadmap, by the way, answered a lot of the question, Clive. So
I think from other industries, and I argue often with my colleagues that the rail industry is more complicated and complex than most other industries, including aerospace, due to the closely coupled nature and the large number of single point failures. But the other industries have been managed to implement things in a couple of years. The key to this is actually not reinventing tools. It's the architecture and data models and the ability to join things up, rather than developing loads of new stuff. So the key part is those key interfaces and keeping those interfaces and data models so they're extensible enough to be useful for the low-hanging fruit of the stuff that you might do in 18 months, 2 years time, but will stand the test of time into the future and don't become old hat and static and you end up moving. So that, I think, is where the challenge is. Once you get to a point where you can prove the worth, then people's tools and suppliers and things will fall in line, because why wouldn't you? But the actual environment itself, the architecture is I think the key part, really, and that's where the effort needs to go first.
How big a deal is it for the likes of Network Rail and the client, the people paying for it, to start to want it and expect it, ask for it, and expect to see it in budgets and estimates and bids?
I guess and I would say, but I sit on the outside of the industry somewhat, but I would say that the challenge with this is that no one project is going to do this in its own right. But a program of work very much would benefit from it. And T190, the activities there, the ETCS rollout is an obvious example, but you're not going to do it on a single upgrade. So I think the key is that's where the opportunity is, and perhaps we are in a perfect storm of opportunities at the moment to try and get some of these things off the ground.
Yeah, thank you.
Chris, thank you, Clive. Thank you, Derek. Arvinder, I noticed you asked a question. We're asking a question about Clive and Heather on the integration with existing systems. I don't know if you'd like to bring that one up, because I think that was quite a good one as well.
Yeah, hi Clive, hi Heather. I think it's been addressed through some of the conversation, but I mean, ultimately, the models that we develop they're as good as the information we put into them. And I think you touched on the drive really is the requirement. What are you trying to model? So, and correct me if I'm wrong, you don't necessarily create a full, whole-blown reflective model of reality.
No.
And so I suppose in terms of practical experience, how have you found how well are interfaces defined? I suppose I bring a bit of my own experience from rail that I found interfaces are not really that well defined. In how do we proceed there? Do we make assumptions in our model, or what?
Yeah, so and it's generally in our understanding of systems in general, railways or otherwise, things fall down at their interfaces because we don't understand them, and interfaces are generally complex rather than complicated, where complicated is rule-based and complex has things we don't really understand very much in it. So you're right, the interfaces are the key challenges. I think in terms of again, sort of some of the things we said before, that actually if you get the right architecture, you can get the right models in there. So, your rail simulation can be an Excel spreadsheet if that's all the level of granularity you need, or it can be something that's incredibly detailed with high fidelity if you're worried about microsecond timings. It's fitting the right things together to solve the right problems, and therefore architecture is important, and then understanding what set of tools are right for what set of problems, albeit you're laying that over a common data model and a common architecture, so you can swap things in and out.
Yeah, I know on that point, I know we strive for zero testing, and there's going to be some practicalities around achieving that.
Yeah.
Are we, I suppose, from what we've worked on at the moment, are there clear model limits? Which areas that can't be simulated that require that?
Yeah, yes, I think there are, but equally I think there are things that we're not testing when we think we're testing them in today's world either. So, you know, like environmental changes, those sorts of things, we sort of glibly think we are testing some of those things, and we're not. So I think the thing we probably have more chance of doing here is actually thinking more carefully about what we can do in a digital world. And that could be, for example, changing the coefficient of friction of our trains to a whole variety of different braking curves, and understanding that we're actually in the real world, when we do our test, we're actually really limited around some particular instances of capability. So that I think there's horses for courses here, but the key thing is, I think, without worrying everyone, I think there are issues with what we're doing at the moment in this space, and the virtual world will help with that, and we just need to understand what's good to be done where, really.
Yeah, definitely huge benefits. Yeah, thank you. Thank you both.
Thank you, Arvinder. Thank you, Clive. Following on from those last few words you said, Clive, if I can actually pick up a point that's been raised by David Clark. Please, I hope you don't think I'm being favours of my boss. I think you certainly won't when you hear the question. David asks, to what extent do we on the panel think that we're preaching to the converted today, and how much missionary work do you think is needed to convert the key decision makers to the way of thinking that we've been talking about, which I think is a very, very good question, actually. And I think although we've had a wider audience for part of it, I think a lot of the enthusiasm is coming from our fellow system engineers. So does anyone have a view on that? Andrew and Derek particularly, I'm thinking, obviously. And Derek, I see you've got your hand straight up there.
Yeah, this is as much to talking to our colleagues across Incosi in different sectors and countries. It's never good enough. It never stops. You can never, if you do get in the room with the people and you do get the message across, you can never back off. And even the people that we think are doing really successfully are constantly worried about losing it, and they sometimes view us as being very successful in that as well. It's just we talked on Monday. We're listening to the voice of the customer, and they are customers. So I don't know. I think you're always striving to do more and never feel like it's enough.
So
I think you only have there's programs going on in other European countries. I quote Argus, SNCF are doing Argus, yeah, and you look at the payback over 35 years, yeah, it's massive, yeah. And so if you just work out the 64,000 SEUs, and if you can get down to, if you can save upwards of £100,000 per SEU, then the elements are there. Obviously, it's not going to be, the payback period is going to be in the earlier schemes, but you can see where it's coming from. So it's the economics that drive all this. We're not doing this because it's a great engineering product or the right thing to do. We're doing it because the business case says we've got to get these costs down to at least £100,000 per SEU, and this and time is everything. So that's where we've got to convince them. And I would say that you probably heard with the shift around a thing called RCA, reference CCS architecture. Well, the European Commission are taking it very, very seriously. I mean, very, very seriously. And they're setting up this thing called a system pillar. Yeah, to literally drive through efficiencies because the unit rate reductions that we can get from digital technologies and the processes are huge. And the European Union are more than willing to fund that. And hopefully, even post-Brexit, we're part of that process through the Horizon Europe.
Fair enough, Andrew. Yeah, thank you. That's a good point. And I suppose really taking from that, what's probably quite key is the importance of us getting this in as an integral part of both the sector deal, but predominantly TR190, as Clive mentioned, obviously earlier, because this will we need these processes as part of that overall program if we're going to if we are going to make the efficiencies. So I think that's where we. I hope that answer is satisfied, David. I'm sure you'll let me know if it isn't. Next one, just Mike. I know you had a question as well for Clive and Heather about whether there'd been any cost-benefit analysis studies. I don't know if you'd like to take that one.
Yeah, just going back to that I think that's always the big question. There's a lot of good technology there that can bring this forward, and but everybody's looking at, well, when does it pay off? What's the cost? What's the investments that's needed? And how do we consolidate that with the other resources to migrate this in some kind of strategy? What do you know about that? And is there things that we should be looking at?
So we haven't done a detailed cost benefit of this, albeit we know that has been done in other sectors, and you know, you can do something fairly high level, particularly if you're focusing on both this reduction in testing and you're focusing in this actually time to test. Is that you could do something incredibly detailed, but fundamentally those two things are going to be your big pots of wins. And certainly there, you know, a fag packet calculation says that there are significant benefits to do that. That's obviously not what needs to drive the industry forward, is a fag packet calculation, but fundamentally there are some big pots there to be had, as long as you know, the assumptions you make in the same as any cost benefit, the assumptions you make are true in terms of reality. But I think we know from, and again, that really is the horizon scanning and feasibility side, is we have confidence that there's enough done in other sectors that's not necessarily the same, but has strong similarities with what we would want to do, that would give us confidence that would be achievable.
Okay, thank you.
Andrew, I noticed you had your hand up there as well. So
yeah. So we are running as part of T190 and in conjunction with the sector deal, we're working collectively now. It's good to say that to try and work out what the cost, the benefits profiles and the cost reduction profiles look like from the various initiatives in both programs, and that's a key element into the Network Rail CP7 planning. So that's what we're going to try and do, and that should, and we're looking at when the capability will become available, such that we can then put that back into the plans to see, well, when the unit rates are going to come down on the ground, because there will be, obviously, if we make a unit rate reduction available in 2 years, but there's not a project to actually do it on for 3 years, and so they're the type of things we're trying to work out as to how we integrate what comes out of the R&D space and what is picked up by the projects as they move forward. Then we can understand when those benefits flow through, and then you can obviously do the cost to benefit analysis against that. That's what we're intending to do as part of T190.
Thank you, Andrew. And also thank you for answering a lot of your questions on the fly in the chat, Andrew, especially the question about providing access to the documents. Thank you very much for that.
Okay.
If anything help with that, just give it a shout. I'll just I should point out that my colleague Sam has been putting a few questions in for everyone as we've been going along. Sam, is there any of them that you'd particularly like to pick up and ask the panel while we've got the chance at the end, rather than me picking them for you?
Yeah, of course. Hello. So I wanted to ask Paul Whitcomb. I enjoyed your presentation showing off the capabilities of your organisation. I was wondering if you could give any practical examples of the work, because obviously there's huge benefits to what you're describing there. So I was after some, just to set in context the sort of things that you do, some practical examples of the work and the savings and benefits achieved for the clients.
Yeah, so one of the big, so we work in rail in various areas. One of the big areas though that we kind of grew from was defence. And one of the things we're doing in defence is we're working with a large defence company to support them in actually embedding systems engineering into their organisation, and then actually looking at the way they do systems engineering and taking that and actually embedding it then into all the programs that they've got going on, and actually making sure that that systems approach is actually embedded not just in the program, but the programs are working together for the actual end goal. So that's quite a big change program. We through doing that, we integrate our systems engineering capability with our program delivery and our people change. So we're actually not just looking at the systems engineering, we're actually delivering the program and we're embedding the change within that customer as well.
Thank you. Yeah, Sam, I'll thank you very much. Sam, while you're on, I don't know if you want to tell everyone when the next UI is going to be on, by the way, which of course is going to be yours.
I can indeed advertise our RIA wares. So at the close of this UI, we've got another Unlocking Innovation event already in planning, which is going to be running on the 6th and 7th of July. So get it in your calendars now. And the topic of that UI is data-driven maintenance. So that covers everything from knowing your assets, collecting your data, interpreting your data, and very relevant to this UI, changing your business for that new interpreted data as well to bring about better maintenance practices. 6th and 7th of July, it will be held as a webinar event. We're aware the world would be open, but we thought the risk of delivery was a little bit too high to do it in person. But because we are keen to host everybody at our shiny new RIA offices in central London, just down the road from the Houses of Parliament, there'll be a drinks reception open to all on the evening of the 6th of July. Full details are on our website.
Yep.
Thanks, Carl.
No worries, Sam. Thought I'd give you that chance. Plus, also, like I say, let's hope. I do hope that we get to see quite a lot of people in face to face at that time. Hopefully, we can start getting a bit back closer to normal. I think at that point I will close the event here because I think we've exhausted all the questions. Thank you all. Can I just say thank you very much to all the presenters again? Can I just give them another round of applause? Been excellent set of presentations, very lively discussion again, as has been all days of this event. Thank you so much, and thank you all for staying on until 4:30 and answering these questions and answering your questions and getting involved with the panel. If you would like any follow-up, please just let me know. Likewise, if anyone else has any queries or would like to follow up, please just drop me a line. And tomorrow we will be, like I say, having some demonstrations of modelling and simulations tools. Please come and join us for that. And then on Friday, we'll be looking at some of the challenges of implementing this within the industry and some of the challenges the industry faces where hopefully systems engineering can support. So please do join us on Friday as well. But on that note, I will now close the call and thank you very much, everyone, and hope to see you all soon. Please stay safe. Thank you.
Yeah.
You too.
Thanks, everyone.
Bye. Cheers. Thank you. Bye-bye. Bye.
Bye.
Bye. Bye. Bye. Bye. Bye.